Hi everyone, thank you very much for watching this video in which we discuss the most relevant additions to Java 16. Yes, I know I'm late. Java 16 has been released 4 days ago and I only now have the time to record this video, but let's check out the most important new additions and prove them with examples where we can do that. So let me start with the invocation handler addition. So in case of the invocation handler, which is for those of you who might not remember, or if you don't know, a very important tool which is behind the scenes in everything that, or almost everything that we call aspects. So when you have such a functionality in, say, Spring that uses aspects, if it uses the JDK proxy, then you use an invocation handler to create a dynamic proxy that covers a specific instance, and that's basically how this important feature in most of the frameworks, I would say, in Java is implemented. And the addition of invokeDefault method helps us in case we are referring to an interface that declares default methods, which if you remember, they were available starting with Java 8. You can now call the default implementation from the proxy directly. I suggest we try this one so you see how it works, and I have already created here a Java 16 first look project with Java 16. As you can see here, I'm using Java 16, the latest JDK, and I would like you to take a look also in my project structure, and if you want to recreate my examples, make sure that you use Java 16 preview in your project in case you want to also test the CL types, because the CL types are still in preview mode. So you won't be able to use them unless you use the preview mode, in my case, in which the IDE will add the preview attribute when compiling and running my application. Otherwise, again, the preview features will not be, you'll not be able to use them. So that's the first thing you need to be aware of. So you download the JDK 16, you create a new project. I'm also using an early access IntelliJ in my case to make my life easier with working with the Java 16 project. And let's create a first example package. So I say example 1. And in example 1, let's assume we want to use a proxy. I also have a video where I explain proxies in more details in my Java Fundamentals stream on this channel if you want to check it out. I'm not going to explain in details now how proxies and invocation handlers work, but if you want to take a look in that playlist of Java Fundamentals, you will find at the very end somewhere a lesson where I describe in detail more about proxies and how invocation handlers work. I will start by declaring an interface, and inside this interface, let's say we have a method which is a default method. That means it has implementation, so say m, and the implementation here is a smiley face. So I want to create a proxy for this contract, a dynamic proxy for this contract. So I'm going to say here example 1, and in the example 1 class I'm going to add the main method, and then to create a dynamic proxy we use the proxy class, and we say proxy new proxy instance. We need a class loader, which is in our case easy to take using the example 1 class instance. And then you have the interfaces, which is what we want to get, in our case only A, so sorry, it should be an array of interfaces like this. And then the third parameter here is actually the invocation handler, which is what has been changed with Java 16. So we need an invocation handler. So let's create a class. Let's call it custom invocation handler. And this custom invocation handler needs to implement the invocation handler interface and override the invoke method. So here you can say, for example, my dynamic proxy over A is displaying a sad face. So remember, in A we had a smiley face, in the invocation handler we have a sad face. Now what happens is that if I use my custom invocation handler here, of course this will act as an implementation for A in my case, and if I call M, then M will be overridden actually by my invocation handler, and instead of seeing the smiley face, which is the default implementation, you will see the sad face, which is what the invocation handler does. Well, what changed now is that you can decide to call the default method. So you see it's the sad face, as I stated, because it comes from the invocation handler. Because this is basically what you get here in is a dynamic implementation of the A contract. So you can simply also prove this by printing out the class of the instance, and you will see that the class of the instance is nothing else than a proxy, a dynamic proxy instance. So this is what dynamically implements the contract A. Now the problem was that we couldn't call, so starting with Java 8 we have these default methods, but what do we do if we want to call the default implementation of M from the proxy? Up to this point it wasn't possible. Starting with Java 16 you can use the invocation handler invokeDefault method. So this is the addition, and you provide further the proxy, the method, and the arguments that you also have from the invoke itself. And when you call something like this, when you call the static method, then it will go and call the default implementation from the interface. So what you will actually see is that instead of the sad face here, now it will display a smiley face, because further now the invoke goes and calls the default implementation, which is the one with the smiley face. So this is a small addition, but is important because it allows us to have a little bit of more flexibility when implementing dynamic proxies, which again, they are really important and they stay at the foundation of many frameworks today, and of what we call the aspect oriented and the aspects in many frameworks today. So having this flexibility will give us advantages when implementing what's behind the scenes in a framework. I was pleased to see this addition. It's a small one, but it's a nice one. So the invokeDefault method. Let's see further what do we have. So day period support added to java.time formats. I smiled when I've seen this. I consider it a bit of a sugar over the Java 16 other features, so it's not that important from my point of view. But now with this B, which was added as a pattern in the daytime formatter, you can actually see in a string representing the day, like in the morning or at night and so on. So we can easily test this one. We can just take it, this is everything out of it, so we can just take it from here and put it in an example. Let's say example 2. Say example 2. Public static void main, and it's local time now, which is late here today. So let's see what it says, probably in the evening or something like that. So, oh, sorry, I also have to, of course, print it if I want to see it. So let's see what happens. So it says at night already, so it's very late, we are already at night. But you can test with different dates, like for example, and say off 10 a.m. Oh, sorry, I think we can leave it in decimal. In the morning, and if we say 13, then this is in the afternoon. Okay, it's a nice feature. I'm not sure if we can consider it really relevant, but it's very easy to test, and it's a nice one as well. And it also says it produces the day period text depending on the time of day and the locale. So I didn't prove it with the local, but it's probably also taking into consideration, of course, where you are on the globe. Then we have a nice Stream.toList implementation. This is a good addition to the Streams API, which has been firstly released with Java 8. So now let's see how does this look like. Example 3, and let's say we have a stream, example 3 again. Let's say we have a stream that I will create, stream with a static factory method, say of 1, 2, 3, 4, 5, 6. So this is my source, it's a stream of integers. And if I want to get it into a list, I can now just say to list, and I get it in the list. So I say list is as to list, and then if you want to print out list, you should see the numbers from 1 to 6. So this is a good addition, because prior to that you needed to say something like, so let me comment this out. You needed to say something like var list is as collectors to list, which is a little bit more to write. So now you have the possibility to easily transform the list, the stream in a list, without needing a collector like I need to do starting with Java 8 and up to now. So this is the today's syntax. This is the old way of doing the same thing. Then I'm going a little bit down below, and I'm going to discuss so all of these are mostly additions to the JVM. I won't discuss them. Records, they finally are out of the preview mode in Java 16, so you can now use records as part of the language without needing the preview flag. I will remind you how records looked like. I presented them also in previous videos for Java 14 when they first started with the first preview, and then Java 15 when they went into the second preview mode. I will now remind you how records work and what they are, but I will also let you go back to those videos if you want to see them in more details. I don't want to take all of your time now. You might be already aware of them. But what's important to remember is that now they are no longer in preview mode. So that's what Java 16 comes with. So example 4 here, I'm not sure I wanted first to create the example 4. You see now IntelliJ is also giving you the possibility to create the record, but it's nothing more than just a class. Instead of using the class keyword, you use the record keyword. So you say point and then create it as a record. Instead of class, you have the record, and then you see this nice syntax which looks strange, or at least up to now looked strange for a Java application, where you have the round parenthesis immediately after the class name. Here is basically where you can enumerate the parameters, and this is equivalent to what you would prior say as this is a final class. So say public final class point, and then you would have to declare private final x and y, and then you would have to create also the constructor to take from the parameters the values and assign them, because the fields are final, so you need to give them values prior to being initialized, which means you need to create a constructor for them and also getters. So it's a lot of code that's replaced only with one line, we could say in this case. And of course, like in any class, you can still add methods if you'd like. So say you want to print out x and y, and you want to just write a method for that, so you can still do that like in a normal class. But now it took a lot of the boilerplate code you'd have to write in this case. So making the fields final, creating the constructor, creating the getter. So now I can use the point now. So I say point p1 new point, and my parameters, it simply looks like a normal instance. It's actually a normal instance of a class, you can consider it, and then you can print the x and the y like you do for any normal instance. But the idea is that the fields are final by default and all that boilerplate, so it's an immutable instance. All the boilerplate code needed to create the immutable instance has been taken out. Records are nice, however there is still a debate there between using records or using Lombok, for example, which is an extremely nice tool where you can also take out the boilerplate like records do from such a class, and you can do actually many more things with Lombok besides that. And for example, one thing you have to take into consideration is that record, it looks great for a model class. So it looks great for a class like data transfer object or an entity. But for an entity, for example, for a JPA entity, you wouldn't be able to use records because of at least of the characteristic of declaring the fields as final. Remember that JPA, the JPA specification, and that implies all the implementations such as Hibernate or Eclipse Link that fulfill the specification, they need the attributes to be non-final. So because of that, you won't be able, or at least for now, for sure, today, you won't be able to use records as entities, as JPA entities, while you can add your Lombok dependency to the IDE, and at least myself, I'm not sure if I would like to have my JPA entities today without using Lombok, because you know, with JPA entities, they map tables in the database, so you might have a table with 7 columns, then you end up with 7 fields, and then about 60 or 70 more lines for the getters and the setters. And if you use Lombok, you just reduce those 60-70 lines to a couple of annotations, and that's why I consider Lombok very, very useful with JPA entities. Records can't do that, so they look nice. They are nice in different situations. When you find yourself writing an immutable class, and that's not something you expect a specific framework would use it by reflection to inject something into the fields directly, then records are fine, and they will probably take out a lot of your boilerplate code. But say you already use Lombok in that project, then it will become sort of a question: should I only add one more annotation over the class, or should I make the class a record? Which is the best to do? Of course, it depends. The answer is it depends, as always. But sometimes you will probably find using Lombok an easier alternatives to records. But the new addition to the language is awesome. I like it, and I hope to see it used in future applications in real world scenarios, being that this is the first version of Java where the records have been added as general available. I didn't have the chance to see records used in real world scenarios, but I'm certain that at some point I will find them in projects out there. And we all know that Java 17 will be released by this fall, and Java 17 is the next long-term supported Java version, so most probably a lot of apps will start using Java 17 by the end of this year. Now let's go back. The next is the pattern matching of instanceof. This was also introduced with Java 14 if I correctly remember, and this is again the first version where you see it like the records as being general available. So it's been through the first and the second preview, and now it's general available and you can use it. I will demonstrate it again in an example just to make sure you remember how it looked like. So example 5. I'm not sure if it worth to say that even if maybe you won't see quite soon everything, all of these features used in real world scenarios, I do expect when the next version of OCP certification will be out there that you will find plenty of questions from records, the instance of pattern, and sealed classes, which I will later present. So make sure you learn them if you want to upgrade your certification, most probably at the beginning of 2021, as it usually happens. You will have a new version of the Oracle certification, and that for sure will include all this stuff as well. So what I do, I make sure that I learn them version by version so that I don't have to then learn next year everything that has been implemented starting with Java 11 and up to Java 17. So it's easier for me to learn them gradually, and I do recommend you do the same. We were discussing the instance of, so example 5, and in example 5 here, the instance of pattern, instance of, it's very easy to understand. So say I have the number class from Java Lang and I assign it an integer, then what I would, prior to the existence of this syntax, do if I want to cast it from a number to integer, I would do something like instance of n, and then I'm going here and I say integer instance of integer, and then I go here and say integer I cast to integer, and then from n, and whatever I'd like to do here with work with I. Now it's the syntax you've seen up to now. In all the cases you'd needed something like this. I prefer to avoid castings like this one. Usually they tend to imply I might not have written the correct class design in my experience, so I don't very often get into writing stuff like this in code, but sometimes it happens. Sometimes it happens because you don't have an alternative. Maybe you are using a library or a framework where you really need to do something like this. Because of that, and this is a code. This code is too long. Why should I cast it here? Where in almost all the cases where you would write a condition like this one, it would be followed by a line where I cast the value, because the reason I'm checking it with instance of is of course because I want to know it is an integer, so I can then cast it without then getting a class cast exception when I run the application. So because this happened in maybe 99.99% of the cases, the idea was, okay, take this out and simply add an I here, and now this is the same thing. I can do whatever I want with I, which is an integer. The condition is still added. The cast is implicitly done by my application, and I don't have to do it myself. What's important to see in this example is that the condition might also become more complex. Say and I is 10, so you can do something like this. I do not recommend you use complex conditions. I prefer to keep the conditions independent, and that's for, of course, keeping the code easier to read. But in the certification exam questions, you definitely don't have that privilege, so make sure you also train your eyes with seeing complex conditions, and that's valid for any kind of example, whether it's with instanceof or not, for the OCP certification. And you have to make sure that I is not actually usable in any case, in any scenario, so you have to properly think about if I is or not available in the condition, because for example, if I would have used an or condition here, then you can see that IntelliJ marks it with red. And if you think now of what you've written, when you use an or, it might also be that you get here when this condition is false. In the first on line 13 here, it will never go on the right side of the end operator in case the condition is false. So in this case, it's normal that we can add a condition right after the end operator. Yeah, because if it was false, then automatically it was keeping all the whole condition. So that's why here, you know, on the right side of the end operator that I clearly is an integer. So that's why I'm allowed to use this syntax. But when you use an or, that's not the same thing, because in case of an or, you have the possibility to have the first condition, which is on the left side of the or operator, as being false, and then it should go on the right side and check this condition. But then I cannot exist here, because if this one was false, then I hasn't been declared. I is declared only in case it is an integer, and that makes sense, because that's the whole purpose of this instance, of to cast the value from the number to the integer. And the same thing it goes if you use the single and the non-short-circuited AND operator, where you know that even if it's an AND, then this operator implies that both sides are always tested. So that's the same case here. So an or a non-short-circuited AND wouldn't allow you use I on the right side of the condition. So you have to make sure you know all these details when you will attend the next certification exam, because I'm definitely sure it wasn't already created, but I'm definitely sure these kinds of questions will be there. So in my experience, I could already say a large experience with certifications in Java, this is what will happen. So these kinds of details will be there. And then we also have the sealed classes I'd like to discuss, and I think this is the last one I would like to discuss. The sealed classes allows us add constraints on the inheritance. Sealed classes are still in preview, they are in the second preview, so most likely they will be out there in Java 17 as well. So again, most likely you will have to learn them as well for the next OCP certification exam, when that will come out probably next year. I'm speaking about that about the future. I usually don't want to predict the future, but it happens that I have such an experience with the certification exams that I already started to foresee what will happen in the next certification. So that's why I'm trying to tell you up front what you need to learn and give you this advice of now. Being the fact that we have frequent releases in Java, it makes your life much easier to simply learn the small releases one by one, rather than waiting up to next year and then learn everything. Example 6, where we discuss sealed classes. So first of all, what sealed classes are? They give us the possibility to restrict the inheritance chain. So we can say that a specific class can be inherited only by other classes, or a specific interface can be inherited only by other specific interfaces. Now, if I have a class A, then I can say it's sealed, and then I have to declare which other classes can extend it. So if I have a class B and B extends A, then one of the things I need to say is I need to go to A and say that B can extend it, and then you can have as many classes as you'd like here enumerated. If you'd like to have more classes that can extend A, this is the first thing. And secondly, in B now you have three options for declaring B. You can say it's final, and if it's final, then nobody else can extend it, so it doesn't matter whether it's extending or not a CL class. So now you see this is a correct syntax, because B is final, it cannot be extended. It extends A itself, and A allows B, so it's one of the permitted classes in A's inheritance chain. Then you could have said this is sealed as well. So if it's sealed, then again B needs to specify the permits, and then say I have a class C. I won't demonstrate it also with interfaces, but it's the same thing there. So then I say this is the final class C that extends B, and B permits C to extend it, and this is how it looks like. And again, C can be final, or can be again sealed as well, and it has to declare who else can extend it. Or if you want to make it non-final, and allow other classes to extend from C, then you have to mark it as non-sealed. So you have to explicitly say it's not a sealed class, but it's neither a final one. I allow other classes to extend from this one, and then of course any other class will be able now to extend from C. So CL classes are a way to restrict, a way a class can use to restrict who can inherit it. And maybe you're asking, why is this important? Isn't this just more verbosity added to the language? Why, when would we do something like this? Well, it's actually a very important feature. I remembered at some point I had to use a library in one of my applications, and I had this problem. It was prior to Java 9, and in some Java 7 or 8, I don't remember, but it doesn't really matter. The idea is that when you have such a library and the poor documentation, and you end up with having a lot of classes, and you don't know which of those are you able to, which of those should you use, should you maybe instantiate or maybe extend classes or interfaces. And the idea is that with such a functionality, it allows a developer that implements a library that will be then used in many other applications. It will be added as a dependency to other applications, and it will be used to specifically mark the classes that shouldn't be extended outside of the library. So why is that very useful? Because now, of course, documentation is important, but even without the documentation, or without reading the documentation when you write code, because all the developers have first the temptation to write code rather than read the documentation, prove me I'm wrong, now you basically see that you shouldn't implement a specific interface or extend a specific class because you see it's sealed. So it's very, very easy. The library tells you that way, this is not a class or an interface you should extend. And this is excellent because it limits if the libraries would use this mechanism, they would limit the way we use them, and it would make using that library a lot easier. So now, by using both the documentation but also having the proper restrictions, we know precisely and faster how can we use a specific library. So such constraints, maybe they are not that valuable in an application, in a normal app you create with Java. But if you write a library, then they are really valuable for those who will actually use the library. And now that I discussed this subject and I refer to libraries, then the Java 9 also added the modular system, and the modularity is also one of the nicest things you could use when writing your own library, because by using a module, remember that you can specifically say in the module info file what the module exposes and what the module consumes. So when you write a library and you write it modular, first of all, if it's composed of multiple modules, based on the module info file, you can expose from one module specifically to another module. If you don't remember this syntax, you'll for sure find another video on this channel in the Java Fundamentals playlist where I describe modules. And I think you actually find more than one video about modules in this channel. But the idea is that with modules you can have a specific module exposing something only to another, or only to some specific certain other modules, which is also great for writing libraries, because when you have module A that it's exposing something only to module B of the library, then again somebody taking the library as a dependency in their app, they won't be able to use that even if it's exposed to be used outside of the module, because the module A declares precisely that only another module of that library can use it. And with these restrictions, you make your library easier to use, because you precisely tell the user of the library, which is the developer that will use that library in their application, precisely what they are able to use. So with CL classes, you tell them precisely which classes should they think about extending, or interfaces should they think about implementing. With modules, you expose to them only what they should consume. And with all these restrictions, if you use them in writing libraries, then you will write excellent and easy to use libraries. If you also cover all the features in a nice documentation, then for sure your library will be very, very easy to understand and to use. And of course we have many other things that happened, like some of the features have been removed, or at least they have been marked for removal, like in case of the applets, some methods from the thread group, they have been terminally deprecated as well. I won't discuss all the details because it would take us more than a day to discuss everything here. I wanted to go through all really important, straightforward changes in the language or additions to the JDK. But I do recommend you strongly to take the release notes and read them yourselves. And of course, if you have any questions, let me know. Use the comment section or find me on Twitter or on LinkedIn, and let's discuss these new additions like we discuss any other subjects. Thank you very much for watching this video, and have an excellent time for learning. Cheers!